So today I'm going to build a couple of models for examples so you can walk through these at home if you'd like. So the first one is from the simulation 2 slides. On the last slide, slide 43, we had the flu clinic model. So we're going to have two nurses in a set, and we're going to use cyclical selection. So the patients are going to be arriving according to an exponentially distributed with in arrival times with mean of 2.5 minutes between arrivals. So let's go ahead and start with that first. So we'll go over to Arena, start with the create module. I'm going to call this patients arrive. The entity type is patient. And random exponential, the value means value between arrivals is 2.5 minutes. So we need to change that hours to minutes. And we're having one patient arrive at a time, and we can leave the max arrivals and first creation at their default values. Let's go ahead and set up that set. So we want to set up the set before we use it in a process module so that we don't have to go back and specify that later. So I'm going to rename this set as nurses, and click on 0 rows to add members to the set. Double click to add 2 rows. So I'm just going to call this nurse 1 and nurse 2. Alright, so you can just click out of that, and we have our 2 nurses there. Alright, so we now have the 2 members in our nurses set, and now we're ready to go ahead and add the process module. So going back to our statement of the problem, we have the time for the flu shot to be given is triangular distributed 1.5 to 3.5 minutes. Let's go ahead and add that in. So we click on the create module, we can then drag out the process module and have them automatically connect. I'm going to call this flu shot given. And because we're using a resource of a nurse, in this case from a set, but it's still a nurse resource, we're going to use the action of seize delay release. So we add the resource, and the resource type is a set this time instead of just a regular resource. We've already set up the set name of nurses, so we can specify that set name nurses. There are 2 nurses in the set, but we're only going to seize 1 nurse. That's the only number of nurses that is required. And I said we could say cyclical. And looking back at our problem, we have that the patients who waited want to come back to the same nurse. So while we're in this process module, we want to save the attribute of the nurse that was used so that we can refer back to that nurse in a later process module for the patients that wait. So the save attribute, we can call it nurse seen, something like that, so that we can then refer back to that attribute associated with each patient at a later process module. And click OK. I'm going to do a triangular distribution in minutes. 1.5, let me go back and look at the numbers here, to 3.5. Okay. So 2 and 3.5. Okay, and then we can say OK. Alright, so the next thing we want to do is we're going to have 25% of patients wait for a 20-minute observation period, and then those will continue on to have a check-in with the nurse before they leave. So the first thing, in order to have this 25% of patients wait, we need to have a decide module to specify this. So we're going to drag out our decide module. Decide about wait is what I'm going to call it. You can call it anything you want. And this is two-way because we want them to either wait or not wait. The types could be two-way by condition or two-way by chance. And so we're going to do it by chance because we don't have any attribute associated with the patients that we're making this decision on. So two-way by chance. And I'm going to say 25% for the true side. And those are the 25% that I want to continue on to process module. So this will be the 20-minute wait. And here, the logic action that we need to specify is just a delay. We're not using any type of resource during this delay, we're just having a regular delay. And it's a constant delay of 20 minutes. You can change the allocation to non-value added if you'd like. Doesn't really matter for what we're doing, but in your projects you might want to specify the allocation of the time. All right, and then those patients are going to continue on to see the nurse. So revisit with original nurse. And here again it says cease delay release because we're using a resource of that nurse. We're going to then still specify the type of the resource as a set. We're selecting our set name nurses. We're still using one unit. And instead of cyclical, now we're going to choose the specific member because we want to see that same nurse that we specified, that we saw in the original flu shot given process module. So the set index is going to give you a list of attributes if you pull the drop down menu there. And so we see a lot of information about the entity, like entity picture, entity type, and then the last one on the list there is nurse seen, and that's the attribute that I assigned to that entity when they came through the flu shot given process module. So that's what we want to refer to. We're telling this resource box here that the selection rule for the nurses set is a specific member who's defined in the attribute nurse seen for this entity. And click OK. And then we have a constant delay of 1 minute. After that, they are free to leave. And then we just need to follow up with the false patients, the ones that don't have a wait, that they can just go ahead and leave directly. So choose the connector here and connect it up to the patient's leave. So we've gone through all of our process and decide modules, create modules, and dispose module. And now we need to do the run the model for 10 hours with 10 replications step. So you just go to your run setup. You have 10 replications. The replication length is what we want to change. You can change 10 hours a day if you want below as well. But really what we care about changing for terminating conditions is the replication length. And I'm going to set my base time units to minutes. And that's pretty much what you need to do. And after that, you would just need to run your model. The next model we're going to look at is the walk-in clinic model, and we're going to use this to set up a few scenarios in PAN, the process analyzer. So first we're going to have patients arrive according to exponential arrival process, 12 minutes average time between arrivals, and then they check in with a clerk, see the doctor, check out with the same clerk, and we have 10-hour replication length as well, and 10 replications for this one. So let's go ahead and build this in Arena. So if we go to our basic process panel, we can pull out the create module, patients arrive, entity type patient, random exponential, there are 12 minutes between arrivals, and we're going to leave all of these at the default values. Patients will then check in. And we have a clerk involved here, so we're going to have a cease delay release. I'm going to add a resource, and this time we're just going to use a basic resource and call it a clerk. Okay. And this is triangularly distributed, units are minutes. And going back to our problem statement, we see it's 235 minutes. And next, the patients see the doctor. Again, this involves a resource, so we do sees delay release. And we're going to change the resource name to doctor. And we're seizing 1 unit of that resource. Triangular distributed in minutes with 5, 8, and 13 minutes for the parameters there. Click OK. And finally, they see the clerk again to check out. Sees delay release the clerk. So we're going to add, and this time we can just choose the clerk because we've already named that resource name. And then we're going to use, in this case, a uniform distribution in minutes, 2 to 4 minutes with the clerk. And then we'll set up a 10-hour replication length with 10 replications. So we have our dispose modules where the patients leave, and run setup, 10 replications, and 10 hours for the replication length, and you can change your base time units to minutes. Okay, so you'd want to go ahead and save your model, run it, and that'll generate a .p file, and then we can go to Tools and Process Analyzer so that we can set up some scenarios and run multiple scenarios very quickly with this model. Alright, so we have a new, click the new button here to generate a new scenario. We're going to double click to add a new scenario. I'm going to call this the base case, and you can call it the same thing or leave the tooltip blank. And then we need to browse for the P file. So just go to where you've saved things, and I've called it the walk-in clinic, and that .p file is saved from there. Okay. And then there's a couple different ways you can do this, but you want to basically insert some controls, which again are the things that you want to vary about your model in order to make changes and see what the effect is on output from that. Alright, so I changed the clerk to integer type because it's just going to be integer values that it can take on. I'm going to start another control for the doctor, and you can set it here to integer as well. Okay. And you also could do number of replications. And finally, the last option here is replication length. So we'll leave that as a real number. Alright, so those are all the controls that are options here. As I mentioned in class, the other way you can have different scenarios would be to use a different .p file if you create a different model, where for instance maybe you would change the wait time to 15 minutes or change the, sorry, I'm confusing my models. You change the number of, the time that it would take to see the clerk or different paths, things like that. You could set up another program file and have a different scenario based on that. So let's go ahead and add our responses in that we're interested in. And we're going to choose patient wait time. Insert another response. I'm just going to do doctor utilization and clerk utilization. Right, you could add some other ones. There's lots to choose from for that. I'm going to duplicate this scenario a couple times. I don't need that many. Well, we can go with that. So this one will be called additional doctor. We'll call number 3 additional clerk. And this will be additional clerk and doctor. Right? And so now we need to make the corresponding changes to our controls. So here we have 2 doctors and 2 clerks, and then we'll have 2 and 2 for the additional clerk and doctor scenario. Okay. All right, and so now we're ready to run them. You can select all of them holding Shift down to select all, and you can right click and hit go, or you can use the play button up here. It also is go, or you can go to run, go, there's refresh that flag. There's lots of different ways you can do it. We'll click OK. Go ahead and save the project. Alright, so now you can see it's running through them very quickly, and we've got our results here. So if we look at the base case value, our patient wait time was about 13 minutes, and this reduces to 2.7 minutes with an additional doctor. From the base case, it reduces about 2.5 minutes if we have an additional clerk. And if we have additional clerk and doctor, we get down to less than 1 minute of wait time. So additional 2 minutes about from the additional doctor scenario. Our doctor utilization, it changes in about half as we add an additional doctor to those 2 scenarios, and the same for the clerk utilization. If we click on this patient wait time response column, we can then add a chart related to that. And so the one I showed in class is box and whisker chart, and we're going to leave it as the default of compare the average values of a response across scenarios. So we're doing patient wait time for all 4 scenarios. So let's just make this a little more readable. And so you can see here that we've got comparisons for all 4 of them. In class, we looked at just the first 3 scenarios, and that was significantly different. Significant improvement over that. Other scenarios here, because we're looking at all 4, we're not actually getting significant improvement here. Make it a little bit larger again so you can see it. So that one doesn't appear to be highlighted, or maybe I didn't highlight it, maybe that's why. Go back to chart options. Hold on 1 second. Let me do this again. So we get a chart, box and whisker. Next. Alright, and here we want to identify the best scenarios. And because we're talking about wait time, smaller is better. Alright, there we go. Now it's highlighting it. So we see that we have very little variance in the wait times when we have additional doctors, and that unsurprisingly, when we have both the additional clerk and doctor, that is the best scenario in terms of patient wait time. And so you would have to couple this with the increased cost of having that additional staff, those 2 additional staff members. All right, so that's a brief introduction to PAN. And so we'll continue on with more of this next class.